All right. So as usual, if you have been here earlier, I am posting the form in the chat box. So please fill that out. Make sure that you fill that out. And I will also post the link where you can get professional development, a certificate for that shortly after. It is my pleasure to introduce Miss Katie here. This is our second time together. And it's going to be just as much fun as it was the first time. So Katie Henry is the head of partner engagement for the Microbit Educational Foundation in North America. She is a former STEAM and classroom teacher. She's licensed as a principal and ed tech coach. She has trained more than 3,000 educators to integrate computer science around the world. And you will be very happy that you are here today. I'm going to get off screen, and please feel free to let us know if you have questions. If you want to share your work on screen, just put it in the chat box and I'll pull you up. There you go.
Thanks, Yolanda. I am so happy to be here with everyone. We are going to be programming microbits today. So if you brought a microbit, you're going to want to bring that over to your computer now. If you don't have a microbit, that's okay, because we can use the simulator in MakeCode. I'm going to be monitoring the chat as best I can, but I might miss a thing here or there, so Yolanda is going to be helping to catch all your questions. Please just keep them coming. We will get all your questions answered before we leave today. Okay, so if you haven't introduced yourself yet, please go ahead and do that. I'd love to know who's here with us today. And let's get started. Hi, Ryan. Hi, Lori. Lori, I'd love to see pictures of the Stranger Things box. Yeah, that sounds awesome. Cool. So the topic today is microbit computer science in middle school. And my name is Katie Henry. As Yolanda said, I work for the Microbit Educational Foundation. Our mission is to inspire every child to create their best digital future. And today I want to help you learn how to integrate the microbit into your course, whether that is a dedicated computer science course that you teach in your school, or maybe an integrated computer science course where you are integrating computer science into another subject area. It might even be that you teach another subject area in the middle school and you came to this session today to find out how you can bring more physical computing into English or music or math. So please do let me know in the chat a little bit more about you so that I can continue to share the very best resources. We're going to review 49 activities and 12 units of instruction. You're going to get a chance to program your microbit. Today you'll be making a pedometer, and there will be plenty of time to explore and try out other activities. So you won't just leave having programmed a pedometer, you will have a chance to make 3 or 4, even 5 other projects. So I hope you're excited about that. I am excited about that. And I'm going to just peek over here at the chat. Oh, right, Marcus from Cincinnati. I was just in Cincinnati. Lovely. Oh, look at all these folks. Okay, 5th through 8th grade, computer science, algebra, accelerated algebra. Hi, Becky. STEAM, I was a middle school STEAM teacher. I thought, yeah, that's what I did. I taught 5th through 8th grade STEAM as well. Okay. Hi, Sally. You support CS teachers. Excellent. Oh, you're in the right place. Loving the new Gator and other connector boards. Yeah, the Gator bit from SparkFun is nice. 5th through 8th grade CS. Great. Lots of math and CS. General education in 4th grade plus everything robotics. Monica, I taught 4th grade before middle school STEAM, so we definitely have that in common as well. Great. Welcome to everyone. Thank you for sharing a little more about yourself. Hi, James. Okay. Great. So getting started today, I just wanted to quickly review what is a microbit and what do you get on that amazing little board. If you've never seen one in real life, it is super tiny. It is about the size of a credit card and it fits in the palm of your hand. This tiny little computer has 2 buttons, A and B, 25 LEDs on the front, and several sensors on the back, including a compass, a thermostat, a motion detector, and a radio and Bluetooth antenna right up here in the corner. So this will allow you to pair your microbit to mobile devices, so you can program from a mobile device also send messages between microbits with that antenna. Along the bottom here, we have these pins that allow you to connect alligator clips or even actually work by touch. So you can touch the pins to complete the circuit for some exciting things. But if you do wander into the world of accessories, there are over 250 accessories for the microbit. You can start to use this edge connector. And by clicking your microbit into a variety of tools like rovers and projects to make drones, other wearable technology and music technology, you can really bring the full potential of your microbit to life. But on its own, it is a very powerful device, as you'll see today. There's quite a lot you can do with this one tool. Welcome to the microbit family if you are new to joining us. If you are kind of an old member of the family, I hope that you will be sharing some of your projects out today, links to maybe your classroom website or your Twitter feed if you've posted projects there. We do have 25 million students around the world coding with microbit in over 70 countries. As I mentioned, there are 250 accessories ranging a whole span of topics and subject areas. And you can program your microbit in multiple languages, including the ones that you see here. So welcome to the family. We are so excited to see what you're going to create, and we have a lot to share with you. So to get started today, we are going to use a tool called Microbit Classroom. This is a free way to organize and manage a remote learning classroom with the microbit. So you are able to push out code. Students can collaborate by sharing. You can share code between students, and you'll be able to collect assignments for assessment. What's great about this tool? It is student privacy perfect. There are no student logins and there are no student accounts. So as you'll see in a moment, you will create the session and you will delete the session if you wish to delete it or save it. But if you don't save it, the information is saved nowhere and everybody's information is secure. Let me show you what I mean by that in just a moment when we open up the session. What I love about it as a remote teacher is being able to virtually peer over my students' shoulders. It's really nice to see what your students are working on when they have a question about their code. So let's put all this into action and see what it is that I'm talking about by creating a pedometer together. So the first thing you're going to want to do today, if you were able to bring a microbit, is take that USB cord out of the package and plug your microbit into your computer. If you are joining from a mobile device today, you will be able to pair your microbit to your device, but you'll need to follow these directions here. So I'll just drop the link to today's presentation back into the chat so that you are able to follow those directions for pairing to your Bluetooth device. So I'm going to give everybody a minute to get their microbit plugged in. And let's get Microbit Classroom set up. Okay. Excellent. All is well. Okay, so I'm going to go over to the internet, and we are going to go to microbit.org. Yolanda, are you still able to see my screen? Oh yeah, we are. I can see what you can see. We're good. Everybody can see. Okay. So as I mentioned, today we're going to be making a pedometer. With Microbit Classroom, you can use a pre-made lesson, such as the ones you find here in the projects page, or you can create your own lesson. Today we're going to use one from the project page called the step counter. So by jumping down here to step 2, I can open this project in the Microbit Classroom. Thank you, Yolanda, for confirming that. And when I do this, it will generate a new activity that I can invite all of you into so that you can program a microbit. The name of the activity has been created, step counter. I could modify it if I wanted to, like with today's session. So I could say 4 p.m., 6:17. So I can remember exactly which class did this activity. I want to code today in MakeCode, but you could choose Python if you are teaching with this or your teachers are teaching with this in your school. And as I mentioned, only the the data will only be saved on your computer unless you uncheck this box. So if you plan to restart a microbit classroom lesson, for example, tomorrow or later in the week, be sure to check this box so that you can save the classroom to your computer and reopen it later in the week. So with that, we can start the classroom. Okay. So the first thing we'll do is complete the code setup. Then I will share the joining details with all of you, and I'll be able to see what you're working on. After that, I'll show you how to save your classroom. So the first thing is to get the code set up. In this pedometer activity, we are creating a way, just like I was showing earlier, if you were joining in and you got to see my owl, we're creating a way so that every time you shake your microbit, you take another step. I went to microbit.org, but this website I'll give you joining details in just a minute, Monica. So you'll be able to come here in just a second. You're welcome. Okay, so when I first start the code, we're setting the steps to 0. And each time I shake the microbit, I'm changing my steps by 1, and I'm showing the steps here on the screen. So this activity was a pre-made activity, so the code is complete. But if I were walking you through this as a class, I might show you how to create a variable, and I might show you how to bring these two blocks together. And in this case, just for our small demo in today's workshop, I'm going to separate these blocks and share the code with you and invite you to rebuild them. It's just a simple activity for you to try downloading to your microbit. Once you get this code and you build your code, the next thing you want to do is pair your microbit to MakeCode. So when I click these 3 dots, I'm able to connect this website, MakeCode, directly to my microbit. So pair device. Be sure to select the microbit in this drop-down menu here and connect it. Now, when I click this download button, my microbit will flash yellow over here, and we transferred the code. Okay, so let's give everybody here a chance to try that. I'm going to share this code with you. Maybe. Code. And now here is how you can join the classroom. Go to microbit.org/join, enter this classroom name and PIN number, and you'll be able to create your pedometer and download the code. So I'm going to give everybody several minutes to try that, and I'll be here to answer questions in the chat. If you don't have a microbit, I hope you did also see that the simulator worked as a demonstration as well. So everybody's invited to try, even if you didn't bring a microbit today. All right, Jeremy is the first one to enter. You get the cookie. Congratulations. Lori and BT are in. Excellent. So as the facilitator, I am able to see students joining, and this is where I'll be able to virtually peer over your shoulder as well. If you're just joining our session today, please be sure to go to microbit.org/join and use this classroom name and PIN number to create a pedometer. For those of you who are working on this activity and have clicked finished, you may want to open a new tab and go to microbit.org and start exploring some of the other projects. So we'll hang out here for another few minutes. I see lots of people working on their code. I don't want to interrupt the work that you're doing. I'm putting a new link in the chat. So as you finish up making your pedometer, be sure to go to microbit.org and click on projects. Also, just letting you know, we'll be looking for folks to share their audio and video today to share projects that they are making. So if you'd like to share now the pedometer that you made, it would be great to hear from you. So just please click the request to share button at the top and Yolanda will let you in. The simulator is pretty cool. For those of you who are with me here in the hop-in room, I'm just going to model that it is possible to click on a student's name and see their project. So for example, I can click on Marcus's tile here and it will load Marcus's project. So I can see, yes, he did create a step counter and yes, he is finished. Great. Okay, we'll spend just about 1 more minute in Microbit Classroom, and then I am going to end the session and show you how to save it to relaunch it. All right. I hope you found this activity helpful for you. If I could now invite everybody to come back into the hop-in window so that you can see the screen that I'm sharing, we'll show you how to save your classroom. Okay. So at the end of the session, you'll notice that some students have added an emoji to show that they are finished, and others still say in progress. That's okay. Students can end the lesson at any point, and you will be able to relaunch the classroom with them back where they left off the day before. All you have to do is come up here and click Save Classroom. And it's numbered for you, the process. So step 1, download the classroom HTML file. And that produces this little file here, which is downloaded directly to your computer. And then I can end the session. Okay. So right now, everyone should have been logged out of Microbit Classroom. So if your window is still open and you go over to it, you'll see the session has ended. But now, to relaunch the session, you can see I'm back here at this main classroom window again. All I have to do is just drag the downloaded file over this window here and just let go. This will allow me to resume the classroom. And here's the name that I gave it, Step Counter, 4 p.m. on June 17th. And I can resume. Now the gives me the opportunity to change the code if I want to modify the code that everybody had. But I want you to actually come back into your same code you left off with. So I'm going to go straight to the dashboard, and I can invite you to log back in again. Notice that the joining details have changed. That is because each session that you create in Microbit Classroom is unique to you. And so it's created live, which means that information isn't being saved from session to session. Nothing is being saved from session to session. So it wouldn't be possible to post these details on Monday and tell students to join and do the work by the end of the week. This is a synchronous learning tool. So you might bring students in for a quick mini lesson, and then like I did today, you might encourage them to go to the projects page, and you might actually have given them a selection of projects, like a choice board to pick from. When they're done with this activity, is a good follow-up. So Microbit Classroom is good for synchronous learning. I'm just going to peek over here and see if anybody has any questions. Okay, so far so good. That's great. Now, okay, great. I think we're doing pretty well. Fantastic. So that is how you generate a lesson, a pre-made lesson at microbit.org. You can come into projects, you choose any of the projects that you see here. You can filter by Python even, and find some really great activities to use in Microbit Classroom. Just notice up here that to actually see the Python code, you have to toggle over here to Python, and then you can open it in Classroom. You will be prompted to choose again your programming language here as well, just to point that out to you. Okay? All right. So let's come back to our activity here, because the topic today is middle school computer science. Oh, Sunshine, could you please repeat the meaning of use temporary local storage? Yes. What that means is you are saving the classroom to your computer. So let me back up here. Let me just create a quick activity here and show you. So I'm going to launch this. I'm creating a sample code. La la la. When we shake, we want to see a heart. Share it. Okay. So can I have? Can I have somebody log into this classroom? I just need one person to log in. Microbit.org/join. Lime frog helicopter balloon. Interesting. Yeah, this sounds like interesting writing prompt. And the PIN number is 937442. And so what will happen is when I close out of this, Sunshine, once I close out of this, I do have the ability to, thank you, Jeremy, to remember the session without having saved it. So what I'm going to do now is I'm not clicking save, Sunshine, but I'm just going to come back to microbit.org. I'm leaving this window, which ended the session. When I go back into it now, because I clicked use temporary local storage, I have this option here. I can remember the very last activity that I did, even though I didn't save the HTML file like before. And so this is here waiting for me. So I can delete it or I can restart it. You're welcome. Last time, okay, see, The last time I was using microbit, I was using right. Monica and anyone else who might be using Firia Labs to program their microbit, what you're going to want to do before you pair is manually download the file. So if I just to quickly demonstrate, Monica, and somebody in my workshop earlier today had the same issue. So it's a simple fix. Firia Labs. Firia Labs are a Python curriculum company, and they have an amazing little robot that goes with their curriculum. And I just love their workshops, and I love their whole team. It's a really great organization. So Monica, to answer your question, instead of clicking these 3 dots to pair to download, just click download. Wait a minute. There we go. And when you do that, I need to disconnect my microbit. When you do that, you'll get a hex file that goes in your downloads folder, and you're going to want to manually drag that file to your microbit. Okay. So you see here how I just got this file here. So let me come to downloads. Cool. So over here, here's the file. And so Monica, just click the file from your downloads folder and drag it over here to your file manager and drag it into your microbit drive, okay? And that will override it. You're welcome. Okay. Great questions, everybody. Just gonna quickly scan. I think we're on top of the questions right now. Perfect. So in Georgia, your middle school computer science standards fall into 6 domains. And as I mentioned earlier, whether you are exclusively teaching computer science or a STEAM teacher or a general education teacher, I think you're going to find that not only can computer science fit in any one of those areas, great, but the microbit can support you across all your domains. And so just to break it out even further, there are 11 specific concepts within those domains. And what we're going to do now is look at new units of instruction at microbit.org that are aligned to these concepts. So right now, take a minute, maybe write down 1 or 2 concepts, either that you feel really comfortable with or not so comfortable with, and you're going to use those as search terms in a moment to find microbit lessons that align. So, you know, data, algorithms, computational artifacts, so forth. Yes, it does, Carla. Only 1 program at a time. You can write very complex programs, and so it can do quite a lot at one time, but it will just be 1 program at a time. Okay. So these are the topics of our new units. And in this diagram, I've organized them by age. And so the one we're going to look at, just to get a sense of how they work, is Introduction to Cybersecurity. But don't be off-put by these ones that might seem like they are for younger students, because here you will see some activities and topics that I think would work really nice for older students, and you'll be able to modify them to bring them into your classroom. Okay. So over here, the way you can find those activities is at microbit.org. We have already looked at the project page. Now we're going to look at the lessons. And on the lessons page, you can search by age, as I mentioned, 7 to 11, or in middle school, 11 to 14. They're also sorted by programming language and subject area. And the one I'm excited to share with you is Introduction to Cryptography. And notice that each unit is broken out by lesson. We suggest that each lesson is about 1 day worth of instruction. So you might think of like a 45-minute class period. And so where you see this green icon here shows you where the microbit hands-on activity actually comes in. So lesson 3, ciphers and text-based programming. Actually, Caesar ciphers are a lot of fun, but I just looked at my notes. I wrote down, I wanted to show you Introduction to Cybersecurity, making a password generator. So if I just got you really excited about this, you can check that out in your exploration time in a minute. The one I really want to demonstrate is down here, making a password generator. So this is really nice. You see in the lesson plan here, it's estimated time, it's modular, so you can choose the parts that work for you, and it's really clear where to get the demo code. And even within this full unit of instruction, you could take your students directly to the classroom by opening that sample code in Classroom and right away having a lesson that you invite your students into. Okay, so in a minute, if you want to use your microbit to create a password generator, you can come back here to Introduction to Cybersecurity, Lesson 3, Making a Password Generator, and you can download that code to try. A few other things you might want to try in the exploration time we're getting ready to start would be some other MakeCode projects. You could tinker with some of the design challenges that we offer. And if you're teaching with Scratch, especially in 5th and 6th grade, for the STEAM teachers and CS teachers, there are some incredible activity cards that you might want to print off for your students and have for stations or small groups. If you have a multi-week course with the microbit, please check out this free 14-week Introduction to Computer Science curriculum. I love this curriculum because it is modular. You can pull out chunks that you like. It's just so easy to pack. You don't have to do all 14 weeks page by page. For folks coming from a literary background or wanting to make some ELA connections, you can look at the Alice in Wonderland projects. They come from a book, a full book of microbit and Alice in Wonderland projects, but these ones here at this link are free. There are more tutorials on MakeCode's landing page. And then finally, if you want to check out some of those accessories I mentioned, the full guide is right here at this link. So what I'm going to do now is actually just give you time to explore. So please come to microbit.org, click on the links in the presentation. I'm going to drop the link back in here. It's also pinned at the top of the chat. And I want to give you some time now to explore projects, lessons, design challenges, any of those other resources that I mentioned with PowerPoint. We're going to take a good 20 minutes for you to explore and ask questions. Come on the screen with me, debug code together, or have a critical conversation about assessment and instruction. The next 20 minutes are yours. Ryan, to answer your question, the whole lesson. So the unit is broken into lessons, and each of those lessons is what I was meaning. Each lesson is one day. Thank you for asking that question. I'm going to drop the link for the password generator here. If you're just joining us, we are spending the next 20 minutes exploring resources and sharing out, asking questions, and working together. Please feel free to hang out with us. Yes, there are a lot. Sunshine says there are a lot of breakout boards for the microbit. You know, I teach with a lot of different ones, and I'm just grabbing my teaching box here. I have 3 favorites in my box. So this one is called Ringbit. And what I like about it is it holds the batteries right to the microbit, and it has 3 breakout pins here. It's essentially just taking these pins and breaking them out for 3 connections. It's really manageable when you're teaching 150 students a day and you want to get far fast. So Ringbit, I love. A more simple one that doesn't hold the batteries, but does come with this little buzzer on board, is called the Basic. And it also breaks out the pins here on the back. So this one, I believe this board costs about $3, and this board costs about $7. So I'm just going to put that in the chat. So Ringbit is about $7 from Elec Freaks, and Basic Bit is about, what did I say? It's like $3 or $4. I'm sorry, I can't remember. Elec Freaks. And then finally, the other board that I use that breaks out all the pins is called the Sensor Bit. And I can't remember how much this one costs individually. I got mine in a kit with some cool components. Sensor Bit. I would be surprised if this is more than $10. Other breakout boards made by other manufacturers would be like a Hummingbird robotics kit, like I'm dropping in here. And you also have it's the Monster Project. I'm blanking out on the name suddenly. Let me grab another link here real quick. Oh. Searching real quick here. Yep, the SparkFun Motor Bit. You also have GatorBit from SparkFun. I love that one too. Oh, Sunshine, the one I'm trying to think of, I've got it over here. I'm trying to decide how much I want to get up from my computer and go dig through my box. That's the one advantage of running a workshop from home, is you can't forget anything because it's all here with you. I am just going to take a second and go grab the one I'm thinking of. I think you'll like it. So I'll be back in less than a second. Well, literally less than 1 minute. Okay. I'm glad you all couldn't see me just then. I was tearing my shelf apart. Okay. Well, after all that, I grabbed the wrong box. Here's another neat breakout board, though. It is a SparkFun board, SparkFun WeatherBit. SparkFun has an amazing microclimate kit. I really like this. This one's WeatherBit. This would be some really cool weather science for weather science units. And they have this whole kit with great data collection tools. Let's see here. All right. I'm going to keep trying to think of the name of this other breakout board, and I will get it to you before the end of this session. but I do want to check in and see how everybody is doing. Please feel free to drop in questions in the chat or come on stage, I call it the stage, and share with us what you're working on. We probably have another 12 minutes or so. Just remember the name of the person who created the board. So let me search his name. There it is. Here it is, BitBuddy and the Bit Booster. These, here's the link. Sunshine, it's Bit Booster and BitBuddy. I am so sorry it took me 5 years to get there, but we got there in the end. Lori, you also can find it with SparkFun. Excellent. Wasn't expecting a question on all the breakout boards. I do recommend checking out the full accessory guide. There are so many wonderful, wonderful tools out there. So I'm gonna post a link to the accessory guide in the chat. Do be sure to take a look at those accessories. By the way, if you do come to the Get Started tab at microbit.org, you'll find great videos for introducing your students to the microbit. We also, under Get Started, have a user guide, and the user guide breaks out each feature in depth. So you have a YouTube video for each feature on the microbit, which I think works really well when you pair them with projects, which you can search by feature. So sometimes students have ideas for things they want to make, and they all want to learn how to use a different feature at the same time. So if you're trying to facilitate differentiated instruction in your computer science classroom, make sure students know how to search for what they're looking for, so they can find examples of projects that they can modify. So you can search our project page by device feature, and that really is designed for students to get what they need quickly. Yep. Any tips on how to store classroom kits of microbits? Yes. Can you link this too? Ryan, do you want me to link the tips for how to store, or asking about a different link? Oh, link the guide that I just mentioned. Yep, I'm with you. You and I don't know where you are, but we're connected in space. There you go. No problem. So Monica, I store the microbits in hard shell cases. So like the 99-cent pencil boxes. I've got an example. I store my microbits in boxes like this. And what I've done is I actually put a piece of bubble wrap in here so that they're not like jostling around and like smashing into each other. So they're nice in place. I would travel on a plane with something like this. And then you could store them like, class sets. And if you have a library checkout system of technology at your school, a teacher could check out a box like this. I think I saw a question about cleaning things a while back. I'm just going to scroll through the chat here. Do you have suggestions for how to handle safety concerns that parents or students may have with handling the microbit due to COVID-19? Is spraying it going to damage it? You do want to keep them clean. In terms of spraying them directly, the way I would say yes, it is possible for spraying them, depending on how much and what it is, to harm it, like any other electronic. But what I would recommend, you could get like the wipes, and you could wipe off the microbit, like a disinfectant wipe, or if they're at home, if you're supporting home learning, you could use like a little cotton swab, just get it damp with even just rubbing alcohol, and just like wipe it off very lightly. You don't want to submerge it or overly saturate it. When you travel on a plane, hope that the TSA agent is a millennial. Yolanda, so true. You're very welcome. Okay. Well, I'm going to come back here. So really, this is your time to ask hard questions and get them answered. I think we have a great community of microbit users here today, and not just microbit users, but folks who are teaching with a variety of instructional tools. And so please continue to ask your hard questions about classroom management, keeping them clean, keeping them organized, and really no question is a bad question. Very happy to go through something we've already looked at, or invite you to share something that you, anything you would like to share with the rest of the group as well. I am going to leave up these 5 tips for getting unstuck. Sometimes in a CS classroom, it's hard to not become the linchpin. All students are waiting to talk to you. And so these 5 tips come from Karen Brennan's YouTube talk, 8 for 8. So you can watch from minutes 241 to 651. It's a great section. And really encourage your students to adopt these 5 habits of mind. Chances are they're already trying them. You just want to remind them and encourage them to keep using these strategies so they don't get stuck waiting for someone they think has the answer. Because the reality is they themselves should have access to tools that help them find the answer. So if anybody else has strategies for helping students to help themselves, please drop those into the chat or come in with audio and video, and please share them with the rest of us. Vicky's here. Hi, Vicky. I'm so happy to see you. Sunshine, I want to do that too. We should brainstorm together. Let's figure it out. I'm going to put my email here. We could have a powwow. You know, the magic sauce is that we need a person or a team that leads the project. We do need to find a funder for the project, and we need to get our team together and organize it and make it happen. The BBC giveaway in 2016 involved 1 million microbits to every year 7 student. And that really was a product or a project led by the BBC and several other organizations as well. In Denmark, they're doing the same thing with 4th graders. Every 4th grader is getting a microbit in Denmark. And that is another project being funded by several organizations coming together. So we really need a team that is willing to commit to the project and let funders know the project is happening. And then we can start to bring people to the table and make the thing happen. Working for the Microbit Foundation means, I do work for a not-for-profit. So we're not selling the microbit. There is a manufacturer who actually makes and sells the microbit. It's our job to kind of help be the glue and champion every child, helping every child to create their best digital future. So if you're someone like Sunshine who's saying, let's do it, let's get 1 million microbits into the hands of students in the US or even more or somewhere else, please reach out to me. I'd love to hear your ideas and let's see what's possible. I would say anything is possible. We just have to get creative and commit to it. Thank you, Sunshine, for asking that question. Vicki, do you have anything else you want to share with us? You can come on and share some of your cool projects or share anything how you organize your classroom with microbits. Okay. Wow. We're going one-to-one with microbits for at least a grade level next year due to COVID-19. Oh, Vicki, I can't wait to learn from you and hear how you're rolling that out. That's terrific. Okay. You know, I'm not sure if everybody got to these resources when we were exploring earlier, but I do just want to make sure you know about these design challenge projects that are aligned to the Sustainable Development Goals. These are great STEAM classroom projects and really great to integrate with a general education teacher as well. And so you'll find some really diverse projects, beginner, intermediate, and advanced, that do invite students to use their microbit to solve a real world problem. And this might be something that you even want to try right now. These are quick projects and easy to do on your microbit. So I got there by going to projects and then design challenges. And for those of you asking about where to get this microbit, you can find it at the same place I linked you to the accessory guide by going to microbit.org/buy. You can get a class set of 10 microbits for about $149, and that comes with a battery pack and batteries and your USB cable for each student as well. The kit that I'm using today is the Microbit Go kit, which comes with 1 microbit, USB cord, and battery pack with batteries. This is a great kit for training and just trying it out for the first time, but you will save a little bit of money by getting the Microbit Club pack. Yes, Vicki's just mentioning that you can find deals with microbits on sale for $10 each. Yep. Sign up for deal newsletters from electronics companies, local and online. Absolutely. Okay. I want to thank everybody for being here today. We still have about 20 minutes left in the session. And so, again, I'm here to answer your questions, share resources. Let me know what it is that you need, and I'll be very happy to share it with you now, or we can follow up afterwards on email. I'll put my email back into the chat here. Don't be afraid to reach out at any time. I have really enjoyed being here with all of you, and I'll continue to be here and help you out. Is there any advantage to using MakeCode or Scratch? Stacy, it depends on your learning goals. That is a great question. I get asked that a lot. And so one of the big differences between both programming languages is the simulator in MakeCode. Here, when you do open up a MakeCode project, you've got a fully functioning simulator, whereas in Scratch, you're going to have that amazing stage and animation window. So you have a different kind of visual output. It really depends what it is you're trying to teach. And I know Vicki can contribute more about how she uses those tools in her classroom. Yesterday, Vicki had a really great point about not using the pair microbit feature that I showed you earlier, but actually going the long way around and downloading the hex file to the downloads folder and dragging it over to talk about how those drives work. So when you do program your microbit in Scratch, you will have to just do an extra step of preparing your microbit. Here it is. To get ready to talk to Scratch. So you'll want to download a program called Scratch Link onto your computer. And this will allow your microbit to pair through Bluetooth. So another big difference, Stacy, is the fact you won't use the USB cord in Scratch with your microbit. You'll use a Bluetooth connection. So right here, if you look at the requirements for microbit in Scratch, Windows 10, Mac, Chrome, Android. What you don't see here right now is iPad. So iPads with Scratch and microbit aren't compatible. Right now, it just hasn't been developed yet. But you can use it on your Chromebook. So that's pretty cool for a lot of one-to-one Chromebook users. The other thing you'll want to do to prepare your microbit is download a hex file to your microbit so that is prepared to pair with Scratch. So there are just 2 extra steps when you use Scratch with your microbit. You're welcome. We were happy too, Vicki. Thank you for the link of curricular integration ideas. You're welcome, Lori. Yes, Lori, I'd love to keep in touch with you to hear how you use Microbit Classroom with your distance learning, if you end up going that way. If you are just joining us, we are just spending some time reviewing resources, exploring lessons and projects at the microbit.org website, and sharing out ideas that we have all tried for using the microbit in computer science courses. So please hang out with us, join the conversation. We'd love to hear how you're using microbit in your classroom or ideas for trying microbit in your classroom. Something new that we are offering at the foundation are these webinars. So if you're interested, on Tuesdays at 11 a.m. Eastern, you can join us for a approximately 25-minute webinar. The one that we did this week was on the topic of family fun. Next Tuesday, our topic will be home secret agents. So these are great introductory webinars for all home learners. So if you are microbits in the hands of your students right now, you can invite them to join our webinar and we'll go through 3 fun projects that they can try. If they can't make the webinar, you can also find these micro activities here on the home learning page. And they're just set up like the other tutorials. You get a nice little video, sample code, and you can open it right in MakeCode. That's true, Lori. Yes, in the new MakeCode editor that was just updated on, or launched on Friday, certainly wasn't updated on Friday, it's been working on it for a long time. When you come here now, you are prompted to give your project a name. So let's make a truth or dare game. I did that earlier this week. And you can see up here that you can toggle between blocks or JavaScript, but this new feature, as Vicki just pointed out, allows you to toggle now to Python. So that is really, really exciting. Yes, there were so many untitled projects in the past. If you came to a MakeCode home screen last week and you clicked on Microbit, you might see 500 things along here that all say untitled. But now, because you are prompted to name it, it's easier to organize. You can also set your code down in here if you just want to focus on one language or the other. But by leaving it at the default setting, you are I just created an untitled project. Don't do that. By leaving it at its default setting, you can toggle within the program itself. Yes, invitation is open. Any projects that you're excited about that you want to share on screen. Also a really fun time to just practice sharing on screen. I can assure you it is easy and fun. Nothing bad will happen. I hope. We should play truth or dare, and I should dare somebody to come on screen. Famous last words, indeed. Okay. Well, if you do want to make a truth or dare game, I can model that for you here. Let's see, truth or dare. The simple way to do that is to just assign a number value of 1 or 2 to be truth or dare. And so because I only have 2 options, I can limit the random numbers between 1 and 2. Yes, Ryan, I'm going to show you my truth or dare game, and then I'm going to play it with all of you, and we'll see who actually plays with me. So I'm going to show you how to, we're going to create a game. We're going to make a dice, and then we're going to turn our dice into an activity picker with text. So we'll do some fun things. So in this case, when I shake the microbit, I now get a 1 or a 2. 2 means dare, by the way. So I dare Ryan to, I don't know you, Ryan. If I do know you, I forgot. So I'm not picking on you specifically, other than, uh-oh, okay. I have no way to verify if you do this or not unless somebody comes on camera with me. So I dare Ryan in the chat to tell us, I don't know, tell us an embarrassing story from middle school. Or you can just tell us a favorite Halloween costume if you dress up for Halloween. Okay, you can think about which dare you want to pick. In the meantime, I'm going to model how to use a variable to create a string of text that says truth or dare in your game. So right now we're just showing a number, but I want to convert this number to text. Okay, he's thinking about if he wants to play or not. That's fine. The variables toolbox here allows me to create a variable. I can name it anything I want. Here, since I'm going to use the random number to assign it to a string of text, I'm going to call the variable random number. And now over here, I want to set my random number to actually be a random number. And we'll use the same range of 1 to 2 like before. And what if all of middle school was embarrassing? Oh, I'm sorry, Ryan. Oh, man. Okay. Thanks for being so pleasant. Okay. So I really appreciate it. So once we've assigned this random number to be a number 1 or 2, now what we need to do is use a logic statement and set our conditional. So we need to set the condition. So if the number I roll is a 1, I want to actually come over here. If the number I set is a 1, I want to show the word truth. So if random number equals 1, we are going to show some text, truth. Otherwise, the condition will be a 2, which is a dare. And now our game is ready to play. So I click share. Oh, I got dare again. Everybody, this is great. Nobody's joining me on camera, so dare probably isn't going to work again. I won't try. But another neat feature of this is if I wanted to share this code with all of you right now, I could click share and publish my project. And then all I have to do is click copy this URL, drop it in the link here. Oh, Yolanda's here. Hi, Yolanda.
I can't believe Ryan won't come on screen. I know Ryan, and he should come on screen. But yeah.
Ryan, it's time.
Did you see the link that Vicky sent and shared?
Yeah, the video at the end of the page does not play, but you may need, okay, yes. I was just thinking that Yolanda's going to give me a hard time if I don't participate. Well, you were right, Ryan. So another neat feature you might be interested in here is you can leave a comment on the code. This is a great way to leave feedback for your students. So right mouse clicking on any block will allow you to leave a comment such as modify this game so that there is a third option. Okay? Now when I click share and I publish my project, I can send you a URL that has a comment in it. So you could now click on that link, download the code, and complete the assignment. Another neat feature of right mouse clicking is this help section. I think this is great for helping students to have ownership over their project because they don't feel limited by a block they're unfamiliar with. MakeCode does an amazing job of giving you a quick description of what the block does, and you can just get all the information you need right here. And you can also expand out on their website to find even more information. So encourage your students to be brave and to try something new and to try to debug their code by using this help block here. Now, 2 hidden features that are sometimes very helpful. Okay. So, by the way, if anybody does modify this code and successfully gives a third option, I'd like for you to go ahead and share the URL here in the chat and we could check it out. Oh yeah, rock, paper, scissors. Vicky likes to use that one to introduce variables. You can do that. Rock, paper, scissors lives here on the project page. And I'm just gonna actually search for it. I don't wanna scroll 40 days and 40 nights. There are so many projects, I love it. Rock, paper, scissors. So in this activity, there's quite a lot happening. You are setting a variable to choose rock, paper, or scissors. And then students can actually come play the game with their microbits, coming up and shaking them and having a object randomly selected. I'll put this link in the chat as well. There you go. Yolanda left. I feel lonely again. Thank you, everybody, for joining today. This really has been a lot of fun. I love the microbit and all the resources. Oh, she's back. Thanks.
Oh, yeah. I was just in the background. I was looking at some of the resources on the webpage. Didn't want everybody to see me typing, so.
That's okay. No problem. If you need to do that, that's no problem. I didn't mean to make you feel.
Oh, you're fine. I was just looking at the microbit site. Great. I wish Vicky would come online. She seems to have a lot of great insight and has used it.
Yes, Vicky. We want you to come on with us for just a second. You can say hello and all you have to do is say who you are and what you do. We can talk about your role and your work with CSTA and all your amazing leadership with the CSK8 chat. Vicky is an amazing computer science leader in our country and is known in a lot of places. So I say our country, but I don't know everyone and where you're joining from. So I should probably not assume that. We might have people from outside the United States. Might have people from Canada. Not everybody told me where they were from, so I don't know. I asked you to. Yeah.
Vicky said she's going to hook up a webcam, and so just hang on for a second.
Okay.
I saw that somebody earlier said that they got a lot of their microbits or all of their microbits from Donors Choose. Here's Vicky. When I was in the classroom, that's where a lot of my things came from. People just have to make sure you check the match offers because a lot of times you can get stuff like super cheap. Hi, Vicky.
Hi, Vicky. Welcome.
Hello.
Everyone, I'd like you all to give a big round of applause for the amazing Vicky. Vicky could, she says no. Could you share a little bit more about yourself, what you do and how you got started in the work that you do?
Well, I'm right now an elementary CS teacher. In the olden days, before I had kids, I was actually a computer programmer. And then I was a stay-at-home mom. And when my daughter was in elementary school, their school lost their computer computer teacher, and they asked me to take over. And I refused to just watch them type for 45 minutes a week. So I started introducing more CS into classes because that was my background. And so kind of fell into it. And that was about 12 years ago that I started doing that. So, and I am on the CSTA board. I'm the K-8 rep. So if you are middle school teachers and have questions about CSTA or any of that, talk to me. I do the CSK8 chat. I'm one of the moderators on that on Twitter, if you're a Twitter person. So
I just put Vicky's Twitter page in the chat here. So be sure to follow Vicky on Twitter for the very best recommendations and resources, and to know when the next chat is coming up. Vicky, is there a schedule for that Twitter chat?
It's normally the first and third Wednesdays during the school year. We moved the June ones just because of all the stuff going on. We didn't want to do one the first week in June. We just didn't feel it was appropriate to hold a Twitter chat at that point. So we've moved to the second and fourth for June. So actually our last one of the school year is next Wednesday. And then we'll resume again in September. Though we're talking about having one after the CSTA conference, just to kind of recap that one, recap what we all learned there. So we're not quite sure on that. So, but we always promo it, for a few days before, at least, if not a week before, so we post way too much when we do that.
Ryan asked, where are you located? Where do you?
I just saw that. I'm in the Los Angeles area.
Okay.
Lori says she started as a software engineer, raised kids, and then went into teaching. That's amazing.
Yep.
Lori, you should share your video and audio. The good news is there's only 3 more minutes, and then this automatically shuts down.
Yeah.
Nobody will get stuck here.
And she's doing it.
Lori!
You can tell it's the last session of the.
You got me. I wasn't very camera ready.
Woo! Hi, Lori.
Hi.
So, where are you based? What do you do?
I'm in suburban Seattle, east side of Seattle. I teach at a girls' school.
Cool.
So, yeah.
Are you on Twitter, by the way?
I don't do
Lori?
much on Twitter. I just follow people
Okay.
and retweet
Well,
people.
we would love to follow you at being at a girls' school. We'd love to see what you're up to and how you're engaging your students. So if you're comfortable, share your Twitter handle with us before you jump off.
It's just my name, @Lori Quinn. I'm actually really excited to teach middle schoolers this fall. So, but I'm a little scared to do it without knowing when I'm going to be in and out of the classroom. So I'm afraid to make up a new curriculum and then not be there. So I was really pumped when I came in here and saw that you have classrooms now for the micro.
Mhm.
So that might be a really nice way for me to stay in touch with them on and off.
So how are you thinking about this upcoming year? Are you thinking, like, how do you begin to think about it? And we only have 2 minutes left. And I know that's like a 2-month answer.
I don't know. We just ended school like 2 weeks ago. So I think I'm still in the freaked out stage.
Fair enough. I don't think you're alone there. I think a lot of people are.
Yeah. And I think until we're closer and our states have made decisions, it's going to be hard to really know what it's going to look like. It's scary, and trying to build those relationships at the beginning of the year when you're not in the classroom can be tough, I think. So,
Well, I thank you, brave souls. We have 1 more minute, and it's a hard.
it's
Oh, and then as the minute comes up, we have Ryan, who has decided to pop on.
Yeah, of course, for the last like 30 seconds. Sure.
Come on, Ryan. So
he's coming on though.
So hopefully he'll jump in because I just added him. But just wanted to say thank you guys for joining us. There will be try it again, Ryan. It didn't work. There will be some announcements and closing things on the stage in just a few seconds. And Katie, this was awesome. I imagine we will be in contact. All of us probably will be asking you questions, but this was great.
Thank you. Thank you, everybody, for joining. Yolanda, you are the best moderator ever.
Thank you. It was fun. It was fun. Oh, Ryan said everything is broken.
Thank you. Thank you.
All
Thank
right.
you, Lori. Thank you, Vicki. This has been a lot of fun. I can't wait to see you all over in the main stage.
Yes, on the stage. Thank you.
Thank you.
Thank you. Bye.
Bye.